So, suppose let f x be a function defined by f x is equal to, suppose this is only constant into x whenever x is greater than -1 less than 2, this is equal to 0 otherwise. Note that earlier we did x square, now we x only. So, check whether f can be a probability density function of a continuous random variable x for some value of c in R. Okay. So, then find if it is a continuous random variable, then and if so, if f can be a PDF, we denote in short notation probability density function PDF. If can be a PDF, find C and probability x less than equal to 0, and if not, justify your answer. So, now what we will do? So, first of all we will check the some of the properties. So, most important property is that most of the time we check just this minus infinity to plus infinity f x dx should be is equal to 1. So, if you do that, so note that earlier we break whole the interval and we mostly this is it is 0 outside the range of this random variable. So, that is why again this implies the other only the part we have to do integrate where it is non-zero only. So, it is otherwise it is 0. So, we will just skipping all those steps. So, this is -1 to 2 f x dx plus 0, this should be is equal to 1. So, from here we can find the solution C. So, this is nothing but -1 to 2. So, next page let us write. So, this is nothing but which implies -1 to 2 Cx dx, this is equal to 1 because this is the definition Cx. So, which implies this is some constant into x square by 2 minus 1 to 2, this is equal to 1, which implies C into, see that it is x square is 2 square 4. So, C by 2 into 4 minus of minus 1 whole square 1. So, 4 minus 1 it is nothing but 3. So, this is 3. So, this is equal to 1. So, which implies C is equal to 2 by 3. C is equal to 2 by 3. So, we can find a constant here. We can see that it may be a probability density function because whenever it by solution it is given C is equal to 2 by 3. That means, if you take this C equal to 2 by 3, then it is a probability density function. So, it seems it will be a probability density function. Now, we want to find probability of x less than equal to 0. So, what will be the probability of x less than equal to 0? Probability of x less than equal to 0 by definition it is nothing but minus infinity to 0 f x dx. So, what the density function we found? So, f x is equal to C now 2 by 3. So, 2 by 3x whenever x is minus 1 to 2, it is equal to 0 otherwise. So, then because this probability contribute only where this range in the range of this random variable where non-zero density exists. So, this is nothing but minus infinity. So, this is nothing but minus so this will be 0 plus, because some part will be the integration minus infinity to minus 1, this integration it will be 0 because this function is 0, plus minus 1 to 0 fx dx. So, this is equal to minus 1 to 0. So, fx is nothing but 2x by 3 dx. So, then if you do the integration, so x square by, so again 2, so what we found, yeah, 2 by 3. So, this is 2 by 3 into x square by 2. So, this is x square by 2, and then this limit is minus 1 0. So, 2 cancel. So, now if you take this limit, so see that x square is 0, 0 minus 1 whole square minus 1. So, this is nothing but 1 minus 1 by 3. So, but probability cannot be negative. So, this is a negative number. So, it cannot be negative. So, we did some mistake. So, basically it cannot be a probability density function, but where we did the mistake? Here you can see that we only checked these things. Most of the time we check that this integration should be is equal to 1, but we ignore other property. So, one important property is that fx always has to be greater than equal to 0. Here you can see that this density function it is given c into x. So, if you take c positive, so then in the interval minus 1 to 0, this is negative value, this value is negative. Now, if you take this c negative value, so then this interval 0 to 2, this value will be negative. So, fx cannot be always positive for any particular values of a real number c. So, that is why there cannot exist any c which satisfy that fx will be greater than equal to 0 throughout the interval. Hence, fx cannot be a probability density function of a random variable x, because it is not satisfying the property of a probability density function. So, here we just learn that all the properties are very important, and we have to check this also. Whenever some probability density function is given to us, then you have to check whether this is correct or not. Okay. So, let us do some other example. So, some more numerical example let us do. Suppose a function f is given like let suppose if a random variable x has the probability density function, if a random variable x has the probability density function given by density function as follows. So, fx is equal to 1 by 4. So, minus 2 less than x less than 2, this is equal to 0 otherwise. Okay. So, this is called a uniform random variable, because it is taking. So, if you draw the graph of this probability density function, so then you can see that it is minus 2, suppose this is 1, this is minus 1, minus 2, minus 1, this is 1, this is 2, 3 like that. So, it is 1 by 4, suppose this is 1 by 4. So, this is constant, it is 1 by 4 in 2 to, so this is actually 2 to minus 2 to 2. So, this is the graph of this function f(x)x), and it is 0 outside this region. So, it is constant. For discrete uniform random variable, it will take same probability for at most of the point. Here for continuous case, it is taking same probability density values for all the value inside the interval. So, for all the domain in the inside the interval. So, it is a continuous uniform random variables. So, we will discuss more details about some of the special distribution function. So, here, so question is that it is the density function is given. So, find probability that x is equal to less than 1, x is less than 1. Second question is that find the probability that mod x is greater than 1, and third question is that find the probability that 2x plus 3 should be greater than 5. So these are not very difficult. If you have understood, then you can go through it. Just I am computing again for to understand clearly how to find the probabilities using a probability density function. So this density function is given. So how we will find the probability x less than 1? So by definition, it is left hand side, it will be minus infinity to. So this is nothing but minus infinity to 1 fx dx. So but here this density function exists on this interval only, otherwise it is 0. So that is why this is 0 plus minus 2 to 1 fx dx. So this is nothing but minus 2 to 1, fx is nothing but 1 by 4 dx, it is a constant random variable. So this is x 1 by 4, then x, then minus 2 to 1. So this is nothing but 1 minus 2, 2 plus 1, 3. So this is nothing but 3 by 4. So I hope this may be any mistake, minus 1, okay, x less than 1, sorry, x less than 1. So this is fine. So basically it is a uniform random variable. So it will take all the interval same probability if you divide same length. So that is why it is a 4 part. So now this is one part, second part. So minus to minus 1, or minus 1 to 0, 0 to 1, and 1 to 2. So that is why because it is 4 part, it is taking 1, 2, 3, 4. So this is up to third part it is taking. So that is why it is proportional to the probability will be 3 by 4. So that is coming from the mathematics also, and from graphically also you can understand it, because it is a uniform distribution. Now how we will find probability of mod x greater than 1? Suppose you want to find the probability that mod x is greater than 1. So mod x is greater than 1, we can, so it is different way you can do. Directly you can compute by doing integration, or you can take the complement of that. Complement of that will be 1 minus probability of complement of this mod x is less than equal to 1. So why we do that? So because this is 1 minus probability of, if you can find this, suppose first we find this probability that mod x is less than equal to 1. So this probability is nothing but probability that x is taking less than equal to 1, and also x can be greater than equal to minus 1, then mod x will be less than equal to 1. So it is easy to find this probability, because this density function is 1 by 4, this is minus 2 to plus 2. So then minus 1 to plus 1 fx dx. So note that now we are not dividing whole. So here actually it is not required also. So minus 1 to 1 fx dx, because it is non-zero inside the interval. So this is nothing but minus 1 to 1, this density function it is given 1 by 4. So this is 1 by 4 dx. So this is nothing but x by 4. So 1 by 4 x minus 1 to plus 1. So 1 plus minus or minus 1 plus 2. So this 2 by 4. So this is nothing but 1 by 2. So now if we want to find this value, probably mod x greater than 1. So this is nothing but 1 minus 1 by 2. This is nothing but 1 by 2. So that is the probability. And next we want to find the probability that so probability, what is the probability we have to ask the question. So this is what is the probability that 2x plus 3 is greater than 5. So how we can find that probability? So probability that 2x plus 3 greater than 5, how we can find this probability? So this probability is equivalent to, because if you do subtract 3, then this inequality does not, so it is equivalent, this is, if this is true, so then this is also true. So both side you subtract, 2x is greater than 2x, I just subtract minus 3r, 2x is greater than 2. So then this is nothing but which is equal to probability that if you, this is 2x is greater than 2, because 2 is a positive number, if you divide both sides, this is equivalent to say that x is greater than 1. So which is nothing but, if you take the complement, so you can either find directly this probability also, it is nothing but 1 to infinity fx dx. So because x is greater than 1 means this it is less than infinity. So in the this side it is not mentioned, that means like earlier whenever left side it is not mentioned, we take it is minus infinity, whenever it is less than, it is greater than, so it will be it is saying that, So, it is nothing but we can write like this, x is greater than 1 less than infinity, it is saying. So, that is why it is 1 to infinity fx dx, but this is non-zero up to 2 only. So, that is why it is 1 to 2 fx dx plus remaining part will be 0 to 2 infinity. So, this is nothing but 1 to 2 1 by 4, fx is 1 by 4 dx. So, this is the density function, you can see that this is the density function 1 by 4. So, this is 1 to 2 1 by 4 dx. So, 2 minus, so now this is 1 by 4, the integration is x, this is 1 to 2. So, 2 minus 1 1. So, then this is nothing but 1 by 4. So, this probability is nothing but 1 by 4. So, this is some example, some probability density function. Now, suppose you have been given this probability density function and you want to find the cumulative distribution function fxx. How you will find the cumulative distribution function? So, fxx, so find suppose this probability density function given to us like it is 1 by 4 whenever x is greater than minus 2 less than 2, this is equal to 0 otherwise. So, then what will be the find the cumulative distribution function CDF, find the cumulative distribution function of the random variable x. So, we define this cumulative distribution function fxx, it is nothing but probability that x less than equal to x for any real number. So, now you can see that this real number, if it is minus 2 to plus 2, then this density exists, otherwise it is 0. So, that is why this will be nothing but minus infinity to plus infinity fx t dt. So, I am why we are changing the variable, because here x we have already used this variable. So, x is here for the cumulative distribution function. So, if we do the integration, then we are computing the area under this curve ft. So, that is why we are using the different variable. Now, you can see that this will be, so basically suppose how this density function given here. So, this is suppose 1 by 4 here, because this is 1 by 4. So, this is minus 2 minus 1 1, this is 0 2, otherwise it is 0. So, that is why, so this is the 1 by 4 length, otherwise 0. So, now if you do the area under the curve, the area it is exist here. So, if you any x here, suppose if you are taking x here, so this function is 0. So, if this x is less than minus 2, then this probability, so minus infinity to minus x, if you find probability of x less than equal to, sorry, x minus infinity to x is less than 2 minus 2. So, fx dx, so this is will be 0, because x is less than minus 2. So, up to this you are doing the integration, there is no probability density. So, that is why then this probability will be 0. So, this will be is equal to 0 if x is less than minus 2, if x is less than minus 2 greater than sorry, x is less than minus 2 greater than minus infinity. Now, whenever x is greater than equal to, or you can consider less than equal to minus 2 also, because you have, if you are doing minus infinity to 2 minus 2, then this density does not exist equal to 0. So, because it is exist only in this interval. So, now if you whenever you are doing x is greater than equal to minus 2 and it is less than 2, because there will be separate case when it is greater than 2 also, because if x is there, then it will all the integration you will do, this area will be cover 1. So, plus 0, so it will be 1, but x is whenever it is inside minus 2 to plus 2. So, then it is minus 2 to plus 2, suppose. So, because you have taken, we have taken equality here. So, here we can take just a open interval, x is greater than minus 2 less than 2, then what will happen? So, then this is nothing but this probability of x less than equal to x is nothing but minus infinity to x fx dx. This is nothing but minus infinity to minus 2 fx dx, this is 0, and minus 2 to x fx dx. So, this is nothing but 0 plus minus 2 to x fx is nothing but 1 by 4 dx. So, then see that this, if you do the integration x 1 by 4 and this is the x minus 2 to x, sorry, I have 1 minute. Let us do this again because this space issue. So, here we want to find, suppose let x is between 2 to minus 2. So, then what is the probability that x less than equal to x? This is nothing but minus infinity to x. I have to change the different variable we have to take. This is nothing but minus infinity to x. This is 1 by 4, sorry, because density does not exist before minus 2, we have to break it, minus infinity to minus 2 ft dt plus minus 2 to x ft dt. So, this is nothing but, because minus infinity to minus 2, this is 0, 0 plus minus 2 to, so 0 plus minus 2 to x, this is ft is nothing but 1 by 4, this is nothing but 1 by 4 dt. So, this is nothing but, I am just writing, because if you do integration it will be t by 4, t if you limit, this is x plus 2 limit, then it is nothing but x plus 2 by 4. So, that is why it is nothing but whenever it is inside this x plus 2 by 4, this is the cumulative distribution function. Now, whenever x is greater than equal to 2 less than infinity, what will be this value? Because whenever x is, so here greater than equal to 2 somewhere here. So, you will do the integration, you will break the integration, the minus infinity to minus 2, this is 0, minus 2 to plus 2, this integration will be 1, and then 2 to whatever the value x, so that x will be, this integration will be 0. So, that is why this will be always 1. So, again if you want to see this, so whenever x is greater than equal to minus 2 less than infinity, then f of x, so this is nothing but f of x is nothing but probability that x less than equal to x. So, then what will be happen? So, then this is nothing but minus infinity to x ft dt. So, because x is greater than equal to 2, now we have to break this interval minus infinity to minus 2 ft dt plus minus 2 to 2 ft dt plus 2 to x ft dt. So, this will be the total integration, total here. So, then this function is 0 minus infinity to minus 2. So, that is why this will be again 0 plus this is minus 2 to ft dt. So, this is minus 2 to 2, this value is 1 by 4 in this interval plus 2 to x, this is again 0 in this interval, because this is the definition 0, 1 by 4 minus 2 to plus 2, it is 0 in this interval. So, this value will be 0. So, then if you do this integration, this is t by 4, and then if you do the limit, so this is nothing but 1 by 4, this is 1 by 4 into t, sorry, this limit minus 2 to plus 2, 2 plus 2 4, this is 4 by 4, this is equal to 1. So, this interval will be 1. So, that is why this is nothing but 1. So, that we are finding. So, this will be your cumulative distribution function. So, then how this cumulative distribution function looks like. So, you can see that. So, this is 0, minus 1, minus 2 like this, 1, 2 like this. Now, density function is constant, but how this cumulative distribution function looks like? It is 0 up to minus 2, 0 up to minus 2. Then what is the value at 2? It is 1. So, it will be it is a straight line. Suppose 1 is here. So let us, okay. So, this is 2, and then suppose this is 1 here. So, this is the 1, no, sorry, yeah. So, then your distribution function looks like this. This is 1 after 2. So, that is the distribution function. This is the f(x)x). So, whenever x is minus to 0, x is 2, it is 1, and it is a straight line between these 2 points, and then it will be 1. after that. So, this is like a distribution function looks like this. So, this is the one example that if probability density function given to us, then how to find the probability distribution function, probability density function of a random variable given to us, then how we can find the probability density function. Okay. So, most of the random variable, continuous random variable what we just discussed, you can see that this random variable taking some of the finite interval, but it can take infinite interval also, we will discuss that. So, like discrete case also we discussed that some of the finite values it is taking, but infinite values also it can take, we have discussed some example. Here also let us consider this function, let f(x) be a random variable, continuous random variable, be a continuous random variable with the probability density function defined by f of x(x) is equal to c by x square whenever x is greater than 1 less than infinity, 0 otherwise. So, why we took x is greater than 1? Because if you take x includes 0 something, then it is undefined. So, now we see whether c is a constant, where c is a constant, find c and find probability, suppose x is greater than 2 less than 3. So, this we want to find. So, now how we can find this? See here we have to check the some of the important properties of the probability density function. So, what are those properties? F of x(x) will be always greater than equal to 0. So, here you can see that if c is positive, then it will be always greater than equal to 0. Now, the second property is that whenever c is positive, whether this integration in this range -infinity to +infinity f(x)(x) can be equal to 1 for a part some values of c. So, if you do this integration -infinity to +infinity, because it is a density function, if it has to be density function, then it will be equal to 1. So, for this implies -infinity. So, because this is non-zero, it is 0 up to 1. So, -infinity to 1 f(x) dx it is -infinity to 1 f(x) dx plus 1 to infinity, because it is seems non-zero here, minus 1 to infinity f(x) dx, this is equal to 1, which implies, see, it is 0 inside this interval, this is 0 plus what is the value here, 1 to infinity this integration c by x square dx, this is equal to 1. Now, whether this exists, now if you do, so it is a indefinite integral. So, how we will do that? So, basically you have to take a value a here, a is greater than 1, and then take the limit a goes to infinity. So, now we will not do that in a properly. So, just we assume that we know this, how to do this integration. So, this is nothing but we will just take integration here, x to x is -2 plus 1. So, it is nothing but -1 by x. So, this is -1 by x, and this is limit is 1 to infinity. Basically, infinity we are not putting, we will take the limit that this 1 by x as x goes to infinity, what is the value. Now, at infinity, so it is -1 by x, as infinity it will be 0, x goes to infinity, this is 0, and at 1 this is nothing but 1. So, that is nothing but which implies this is equal to 1, which implies this value is nothing but basically here. So, C into this is nothing but 1. So, this is equal to 1. So, basically this constant is coming is nothing but 1. So, next what we will discuss, suppose what will be the probability between 2 to 3. So, then probability that now what we found that what is the probability density function, f of x is nothing but 1 by x square whenever x is greater than 1 less than infinity, it is equal to 0 otherwise. So, now we know the probability density function. So, when we know the probability density function, then we can compute the probability. So, then probability of whether x is greater than 2 less than 3, what will be the probability? This probability will be nothing but integration 2 to 3 f x dx. So, this is nothing but which is equal to nothing but 2 to 3 1 by x square dx. So, this is minus 1 by x 2 to 3. So, this is nothing but 1 by 2 minus 1 by 3. So, this is nothing but 1 by 6. So, this is the probability. So, hope you have understood and following the lectures. So, we have already we completed probability mass function. We discussed some of the important example of probability mass function and how to find probability mass function from probability distribution function in case of x is discrete random variable, and how to find whenever probability mass function is given, how to find the probability distribution function from the probability mass function. So, that we have already learned and some numerical example we have done. Then we completed probability density function whenever x is a continuous random variable. So, how we can define the probability density function, and then if you know the probability density function, then how you can compute the probability cumulative distribution function, what are the properties of the probability density function in case of x is a continuous random variable, and some numerical examples how to find the cumulative distribution function from the probability density function, and also how to compute the probabilities using the probability density function. So, we have learned all this probability classification of the random variable, discrete random variable and continuous random variable. Next, we will discuss some other important measures. This is called the moments.